The question is, there are 5 conformations there. Which one is the most stable one and the rank them by the stability? Then you're going to think about all the things we just talked about. You need to be applying the concept to solve the question, right? That's why solving a question, you need to know the principle, but you still need to know how to use the principle to solve them. It's like a mathematics. Knowing the Pythagoras theorem does not mean that you can solve any question with it, right? It's still in the practice. So what you need to see here is, well, look at that one. That is 3 wheels. I mean, the 3 bonds this way, back one that way. Is that the eclipse one or stable? That's a stable. What about this one? I know the drawing can be fully new, but we kind of got much close here. We're trying to draw the eclipse. So that eclipse conformation. Between the stable and eclipse, I told you which ones are heading on stable, which ones are more stable between these two. Stagger is the more stable than the eclipse in any time. And that's a stagger again, that's eclipse, that's a stagger. So we got 3 stagger, 2 eclipse. But let's just 2 eclipse first. These 2 will be the bottom 2 worst conformation. But how are we going to sort it out? Which one's going to be worse than the other? Is this worse or that's worse? And what concept do we need to use? So I hope you remember that eclipse conformation, you got the big object overlaying another big object, energy goes up because static hindrance goes up, right? Look at what's overlapping with each other. CH3 is on top of each other. That's bad. But if you look at the other one, it's a CH3 on C2 CH3. Is a C2 CH3 FeO groups is bigger, or the CH3 is bigger? Between these two, which one's bigger? I mean, you can easily see that the more atom comes in, it gets bigger. So steric hindrance between the methyl on methyl, steric hindrance between the methyls on the ethyl, which one's going to be worse? The bigger objects makes it worse. So that makes this one the worst. That's number 5. And that's going to be right on top of it. Not bad, but at least better than this one. Now look at the 3 staggered. We got the 3 staggered one, right? Anti, which means the biggest substituents on the farthest each other, 180 degrees apart, that would be the best. But the thing is, we cannot see just anti here because we got multiple substituents. Right? What makes energy goes higher is 2 big substituents 60 degrees apart. I hope you remember the name of the conformation. It's called the gauche conformation. Gauche raise energy. Something I forgot to point out, how much energy it gets higher? About 1 kilocalorie for each gauche conformation. It gets 1 kilocalorie goes higher. So number of the gauche conformation is something that we're going to count. On this one, how many gauche conformations there? Oh, okay. Sorry. Let's talk about this one first. This one, there's a CH3. That's the methyl groups here, methyl and ethyl. Which one's the biggest? Ethyl is the biggest on the front carbon. And then which one's the biggest on the back carbon? Methyl is the biggest. So in a way, that achieves an anti-conformation. If you're just considering only the biggest substituents at each carbon. So you get this methyl here, and then this ethyl, the biggest substituent on each carbon, 180 degrees apart. This looks like an anti. Yet, this front carbon, not only having the ethyl groups, it has a methyl groups. That's the one that gives you a gauche interaction between these two, even though this is an anti. So that's a 1 gauche interaction there, right? If you look at the other one, that one, this is also staggered, but now what's in the gauche interaction, gauche relationship with each other? Methyl with an ethyl. Methyl with a gauche is better than methyl with an ethyl, is because the ethyl is a bigger. They are still staggered, but as the size gets bigger, there's a chance that they get closer, right? So that's why the energy goes higher. So between these two, which one is better? I say this one versus the other one because of anytime you get size up, being in closer distance makes it worse. So that's why this is a better than the other one. Now look at this one. This one has a two Gaussian relationship between these two, this H3 with that H3. That's the gauge, one gauge. And then this H3 with the ethyl, two gauge relationships. So we got two gauge relationships, 1 and 1. So each gauge relationship varies the energy about 1 kilocalorie. So you may say that this one gets 1 kilocalorie higher, that may be 1 kilocalorie higher, but that's going to be 2 kilocalories higher. So that should be number 3. And number 1 is basically comparing these two. That one's probably the best because we got the smaller ones in gauge compared to the smaller one with the bigger ethyls. So this is what you need to do to sort them out.